Okay, this is a simple program that I want to assemble using the net-wide assembler, which is available online, or you can have it from me. How do I go ahead and do that? I didn't do anything special. The first line over here, it tells your computer to start from the memory location 100, as you can see. ORG 100. If you want to start from any other place, you can go ahead and change that. The last two lines means the second last line is telling your computer that the program is ended. This program has ended. And the last one is a termination signal so that the program might exit gracefully. That is the whole thing. The rest of these things, these are means inside the what am I doing? I'm putting 5 into AX. Yes, dear.
For example,
Continue the recording. Now the question arises, how do I assemble this program? I've saved this into a file called mfp, means my first program.asm, and all I've done is that I've gone into the NASM folder. Let me increase the font for this one and we'll come back. So I've increased the font size for this NASM. What I'll do is that first I'll say dir, means directory listing, and whatever file begins with the keyword m. So you can see the only one file that I view over here is the mfp.asm. Fine. I'll use the NASM now and ASM for the first time. NASM means net-wide assembler. Please assemble my program, which is mfp.asm, into a file, means output. I'll say -o, and I'll say, for example, a capital M, my first program.com. Normally we will use the COM or the command line for command line interfaces. I didn't have any errors over here. That's normal execution. If I had a few errors, for example, I put something wrong over here and I save this one and I tell NASM go ahead, and it says that at line number 6 I've got an error, invalid combination of opcode and operands. So you will see most of the times these errors that are over here, as you see with other compilers as well. So I'll remove those errors again. I'll Control Z that, save that again, and means the output now would be my first pro.com. As you see, I've told it, and the only thing that I need is that I need to run that. Means my first pro, even if you don't use the .com and you run that directly, it runs ahead and it's run. It's executed without an output, without anything else. Where is the output? How would I see that the program is running, and so on and so forth? I will have to use another tool which is called the AFD. So in order to do that, let's go ahead and discuss AFD and then we'll come back. Now, the thing that we need is called the advanced full screen debugger. It's actually a debugger that we use. And what are we going to use? We are going to use a command, AFD, means that's an exe file, so that's how I run the exe, and I am going to tell it my first program, the one that I've created, debug this program for me. Do you remember the discussion of the debugger and the compiler?
yes.
Okay, means if you were away. So when I run this now, I see all of this stuff that is going on. Now the question arises that what does it do? Or how do we go ahead and see what is going on in the processor? You can use this one to run a few more exes as well. Now down here you've got step, process step, retrieve information, help on, break menu, 6 is nothing, 7 is up, down, LE, right, and so on. What are we concerned with is how do I process the first step? This is debugging now. So I'll press F2, just F2. So when I press F2, let me at least click on that. Yeah, Ginger is coming. Okay, when I press F2, it's dangerous coming. When I pressed F2, you saw that AX became 5. Why? Because I told to load 5 into AX. That was the first thing that happened. Each and everything that you see over here is controlled through hexadecimal. So as you can see, F's, lots of F's over here and over there, and each and everything almost is done by the. Okay, if I may go ahead and do another step. Now BXA has been loaded, but in my program I told BX to load 10 onto it. So how does that happen? Actually, whenever you are working with computers, therefore most of the times means in 2 classes we discussed about the hexadecimal addition, subtraction, retrieving. So the A is equal to 10. 10 in decimal is equal to A in hexadecimal, if someone of you might remember. So it's loading A actually onto the BX. So when I press F2, that is also done. As you can see up there, the BX has changed to A. Then again I'll say F2 to add AX and BX, which becomes F. So F10 plus 5 is 15. The value of 15 is F. At least you should start knowing your hexadecimal values, at least means the basic ones. Yes, the last digit of the hexadecimal. And when I say again move F to BX, means load 15 onto BX, means this is the line that we are in now. So I am loading 15 onto BX. The value of BX is still A. I change that by pressing F2, means I execute this line of code. So as you can see, the value of BX has become F. Now F plus F would become 30. 30 in decimal. But what would it be in hexadecimal? 1E, as far as I remember. Means 1 and 14 is left. So whenever you divide that by 16. So when I move that, I'll say add whatever is in BX to AX and save it in AX. And when I press F2, as you can see, the value of AX became 1E. And then I would say AX 4C00. So 4C00 goes over there, which goes ahead and ends our program. And when I move the int int 21, it goes ahead and it terminates the program. And that is how you work with the basics of assembly language. Thank you very much for listening.